Hello there and welcome to the question and answer video on differentiation. Here we're going to go through lots of differentiation problems, question answer, question answer, question answer. Before I answer every question, pause the video and try your best to answer that question. So let's just go through the few rules that we have for differentiation. We're looking to do differentiation in the second year of A-level maths here. So the first rule we have is the product rule. And that is, if you have two functions that are being multiplied together, then this is how you differentiate it. You differentiate the first one and then multiply it by the second one, and then add it onto the other way around differentiated. So keep the first function as it was originally, and then multiply it by the differential of the second function. Add the two results together. You can see that it doesn't really matter which way around your f and your g were, because you're going to be differentiating one of them, keeping the other one the same, and then adding it onto the other way around, basically. So the next rule is for fractions. If you've got one function over another function, then this here is the rule. And this is the only rule you're given in the formula booklet, so you don't need to remember this one as much as the other two, but it's still really important you remember it. So in this case, it does matter which way round your f and your g function are. You differentiate the numerator first and then multiply it by the denominator, and then you take away the original f function multiplied by the derivative of the g function, and then divide all of that by the g function squared. And then the last rule is for composite functions, where you've got f of a g function, so one inside function g of x, one outside function f of x, and this is how you differentiate it. You look at what is the function closest to x, or the function that will be applied to x first. In this case that's g of x. You differentiate g of x first, then you differentiate the outside function, the function that is applied second to x, and then you differentiate that, and then you multiply that by the first differential in terms of the original g function. Okay, so these are our three sets of rules, but we also need some base differentials to work with as well. So just a reminder then, sine differentiates to cos, cos differentiates to minus sine. What you'll see me do in this video is you'll see me use a little circle of differentiation if I ever get confused about whether it's going to be positive or negative in my answer. So sine differentiates to cos, cos differentiates to minus sine differentiates to minus cos, and minus cos differentiates to positive sine. So it's like a wheel of differentiation. E of x differentiates to e of x, ln of x differentiates to 1 over x, and x to the n differentiates to nx to the n minus 1. This last rule here, comes from your first year of differentiation. Right, let's get stuck into the first question. And so we have sine of 5x. How do we differentiate this? Well, what we see here is that this is a classic example of the chain rule. One function, 5x, and then applied to another function, sine. So we have one inside function, 5 times x. That's the first function that's being applied to the x value. And then after that, you sine the answer to that. So we say that sine of x, or the sine function, is the outside function. So we've got the inside function, which is g of x, which is 5x, and we've got the outside function, which is the sine function. And the way we write the sine function is just like that, just sine x. So let's start to differentiate now. What we need to do here, first of all, is we need to differentiate the g function. That's the inside function, so it's inside first, inside then outside. So inside first, that would differentiate to 5. And then outside, the f function next, that would differentiate to cos, because we know that sine differentiates to cos. But it's cos in terms of the original g function, which was 5x, so the 5 stays inside the bracket with the x there. So this is our final answer. So by the time you get really good at these and very quick at these, what you'll be able to just recognise is that the 5, if there's a scale factor multiplier on the x inside a sine or a cos, or a tan, it does work for tan as well, that 5, or whatever scale factor multiplier there is, pops out to the front, because 5x differentiates to 5, and then sine differentiates to cos. Okay, so classic chain rule there, classic composite function differentiation. Next one, y equals cos 3x plus 7, so pause the video and have a go at this question. I'll go through it now. So the inside function in this case is 3x plus 7, and the outside function is cos of that value. So let's start to apply the chain rule. So we differentiate the inside first. It always goes inside, then outside. So inside first, 3x plus 7, that goes to 3. And then it's going to be multiplied by the differential of the outside function, that's cos. Cos differentiates to minus sine, but it's minus sine of the already inside function that's there, so 3x plus 7. So I just write my final answer, tidying this up a little bit, minus 3 sine 3x plus 7. Okay. Next one, pause the video and have a go at this question. So we have y equals e to the 9x plus 4. Again, this is chain rule differentiation. We have one inside function that's 9x plus 4, one outside function that's an exponential function. So we get started by differentiating the inside function first. The inside function was 9x plus 4, so we differentiate that to a 9. Then this is going to be multiplied by the derivative of the outside function, e. E, remember, differentiates to itself, so it's going to be back to e, but in terms of the g function that was originally there, it's going to be 9x plus 4. So the answer here is 9e to the 9x plus 4. What you can think here is that 9 is the scale factor on the x, so when it gets differentiated, the 9 will pop to the front, and nothing much happens to the 4, because when you differentiate 4, it gives you 0, so nothing is multiplied onto the coefficient because of this 4. The 4 just stays there, doesn't really do much. Okay, next one, a little bit more tricky then. So again, it's still the chain rule. We have clearly one inside function that's 9 minus 2x, and an outside function which is sine x. So let's get started in differentiating the inside function first. It's always inside then outside. 9 minus 2x we differentiate to minus 2. And the sine function differentiates to cos. So it's going to be cos of that inside function, 9 minus 2x. So that's the answer to this question. Next question, again, chain rule. We have an inside function, 5 minus 3x, and an outside function, cos. So let's get started on the differentiation. 5 minus 3x, the inside differentiated first, that will give you minus 3. And then the outside function, cos, differentiates to minus sine, so it's going to be minus sine of the inside function, 5 minus 3x. Tidy this up, we've got two negatives here, 3 sine 5 minus 3x. Okay, different rule now. Here we clearly have two functions that are being multiplied together, e to the x multiplied by sine x. So in this case, we're going to use the product rule. So the first function we will label as f of x, and the second function we'll label as g of x. So let's get started on the differentiation. So dy by dx equals, and the first thing that comes up in the product rule is the derivative of f. So that's the derivative of e to the x differentiates to itself. The next thing in the product rule is g of x, having done nothing to g of x, so we're still just at sine for this one. So we've differentiated one of them and left the other one the same. Now we're going to do the opposite. We're going to have f of x, which is just leaving the f of x function alone, so that's just e to the x. And this time we're going to differentiate the g function to cos. What we might want to do in a final answer here is just factorise out e to the x. And there we have it, a simplified final answer. So this is a use of the product rule in this case. We can clearly see it's the product rule because we have two functions that are being multiplied together. E to the x multiplied by sine x. One function is not inside the other function, it's just the function e to the x next to the function sine x, which means they're multiplied together. Next one. We can clearly see here we've got fractions, so we're going to need to use the quotient rule for this differential. The top one you always have to label as f of x, and the bottom one you have to always label as g of x. So let's get started differentiating. This rule is quite long, so make sure you don't lose track halfway through. The first thing we need to do is differentiate f of x. So cos x differentiates to minus sine x. Times by g of x. G of x is just the bottom function, so that's just e to the x. Subtract f of x, that's just the f of x function on its own, so that's just cos x. And then it's going to be multiplied by the derivative of g, so e to the x differentiates to itself. And then this is all going to be divided by the g function squared, so that's going to be e to the x all squared. Now what we could do here is we could simplify a little bit and cancel out e to the x on top and bottom, just one factor of e to the x from top and bottom. So it's going to give us a final answer of minus sine, take away cos x, over e to the x. And there we are, that's the final simplified answer to this question. Moving on to the next one, okay, we're back to chain rule now because we clearly have the ln x function inside the cos function. So it's going to be the chain rule this time. We have the inside function that's ln of x and the outside function which is cos of x. So let's get started differentiating. The inside function first, it's always inside then outside. Inside function first, that's 1 over x. Then it's going to be multiplied by the outside function differentiated, that would be minus sine of the inside function, so ln x stays inside that sine function. So to simplify the answer, it's going to be, I could actually simplify a bit more, minus sine of ln x, that's ln x inside the sine function over x. So there we are, that's the answer to this question. Okay, so here we have y equals ln sine x. So here we clearly have one function inside of the ln function. So here we have the sine x function is the inside function and ln x is the outside function. So let's get started differentiating this. Differentiate the inside first, it's always inside then outside. Inside is the sine x function which differentiates to cos of x. And then the outside function which is ln of x, so that's 1 over x. But it's 1 over the g function, which is sine x. So in this case, the answer here is cot of x, because cos over sine is cot. Okay, so there we are, that's the answer to that question. Let's move on to this one. We have y equals ln x times sine x. So here we clearly have two functions that are being multiplied together. One function is not inside the other function, it's just ln x and sine x that are being multiplied together. So here this is a case of the product rule. Let's get started differentiating. So first thing we need to do in the product rule is differentiate the f function. This is the first function, so that's going to be 1 over x. Multiplied by the g function, that's just sine. So we've differentiated one of them and kept the other one the same. Now we're going to do the opposite way around in the next move. So now it's going to be the f function, that's ln x, multiplied by the derivative of the g function, that's the last one, so that's cos x. And this is the answer to this question. Moving on to the next one, another case of the product rule. So here it's clearly e to the x multiplied by ln x. There's not one function inside the other one, it's just e to the x next to ln x, and when two functions are next to each other, that means they're being multiplied together. So this is a case of the product rule. So let's get started differentiating. So the first thing we need to do in this differential is to differentiate the f function. That's the first one. So that's e to the x multiplied by the g function, that's ln x. So we differentiated one of them, kept the other one the same, and now we'll do the opposite. Keep the f function the same, and differentiate the g function to 1 over x. Whoops. And that's the answer to this question. Moving on to the next one. Now, with ln x to the 7, there's actually a few little tricks we can do with ln x to the 7. What we can do is we can use those rules of those laws of logs to help simplify this question. What we can do is we can bring the 7 out as a power. And now it's a scale factor multiplier, and that's a rule of logs. If you've got ln of a to the power of b, then this is equal to b ln a. If it's a power inside the bracket, it's a multiplier out the front. Now, I've just got to multiply 7 lots of, I've just now got to differentiate 7 lots of ln x. So the derivative in this case is just going to be 7 lots of the derivative of ln x, which is 1 over x. So this will differentiate to 7 over x. Okay. Next one, e to the x cubed. So in this case, here it's going to be another chain rule. We have one inside function that's x cubed. That was the first function that was applied to x. And then it's going to be e of that answer. So let's get started differentiating them. Differentiating the inside function first, 3x squared, times by the derivative of the outside function e. Well, e stays as it is to the power of x cubed of the inside function. Remember, it's always of the inside function. So there we are. We could probably simplify this to e to the x squared, e to the x, so 3x squared, e to the x cubed. There we are. Moving on to the next one, we clearly have two functions here, one on top of the other as a fraction, and whenever you've got fractions, it's the quotient rule. This rule is the rule that you're given in the formula booklet, so you don't need to remember it. You need to remember it's there, and you can use it if you want to, but you don't need to remember all the complicated parts of it. Look in the formula booklet and you'll see this. So, let's get started differentiating. What's really important about the quotient rule is you label the top one f and the bottom one g. Otherwise it won't work. So, the first thing in the quotient rule we do is we differentiate the f function. Sine differentiates to cos. Then we multiply it by the g function, that's e to the power of x. Then we subtract the f function in its original state, that's just sine x, multiplied by the derivative of the g function, that's e to the power of x. And that's all going to be over the denominator squared, that's e to the x, all squared. We can cancel out an e to the x on top and bottom here, so that's going to give us cos x minus sine x over e to the x. Lovely, there we are, that's the derivative of this function. Moving on to the next one. We have y equals e to the cos x. Well, clearly here we have one function inside another. The inside function is cos and the outside function is e. So in this case, let's start differentiating. So the inside function first, it's always the inside function first, that's minus sine x, multiplied by the derivative of the outside function e. E differentiates to itself, so it just stays as it was before, e to the cos x. And that's the answer to this derivative. Right then, so moving on to the next one, we've got y equals the square root of 5x squared plus 7. Students generally struggle to spot this one. In this case, it's the chain rule. We've got an inside function of 5x squared plus 7, and then an outside function of the square root. So the inside is 5x squared plus 7, the outside is square root. So let's write that down on the side because it's a little bit trickier, this one. Inside is 5x squared plus 7. Outside, the f function is just the square root function. So the way we'll write just square root is square root x. Or in other words, x to the power of a half. So let's get started on differentiating this. dy by dx equals, so the inside function gets differentiated first, always. That will differentiate to 10x, nice and easy. Then it's multiplied by the derivative of the f function. Now the outside function is the square root. And how do we differentiate this? Well, it's the same as year 1 differentiation. You bring the power to the front and reduce the power by 1. So it's a half x to the power of minus a half. We've brought the half to the front and then taken away 1 from the power, so it's now minus a half. But it's not just this function, it's this function of the g function. So this 5x squared plus 7 is going to get involved where this x is. So it's going to be times a half, bracket, 5x squared plus 7, all to the power of minus a half. Because it's the f function differentiated of the g function. So the g function has to stay inside there. So let's tidy this up. 10x times a half, that's 5x. Then it's going to be 5x squared plus 7 to the power of minus a half. So the next part is now just going to be rewriting this as a surd, so it's going to be over the square root of 5x squared plus 7, because the negative on the power makes it over a fraction, and the half makes it a square root. So there we are, that's the answer to this question. Next one's the product rule, because we've clearly got x cubed multiplying by e to the x. One function is not nested inside the other, so it's just a product rule. So in this case, let's start differentiating. So the f function will be the red one, the g function will be the blue one, so differentiate the f function first, that's 3x squared, and multiply it by the original g function, e to the x. Okay, so we differentiate one, kept the other one the same. Let's do it the other way around now. X cubed gets kept the same, and e to the x gets differentiated, which differentiates to just e to the x. We could factorize some of this, x squared e to the x, bracket 3 plus x, if we wanted to. You don't have to though, this is a perfectly good answer. Next one, square root of e to the x. You'd probably be tempted here to set e to the x as the inside, square root as the outside. Well, when it's an exponential, you could do something a little bit more tricky. You could write this as a power of a half, and now what you've got is an exponential, a power to the power of something else. And remember those laws of indices, if you've got a power of a power, you can just multiply those powers together. So it's going to be at half x. Now we can differentiate, and now it's a bit easier because the inside function is half x, so that will differentiate to a half, and the outside function is e, which will stay as it was. So that's a good final answer. You could also write it as half square root e to the x if you wanted to as well. Next one is sine 1 minus x squared. So again, this is the chain rule. We've clearly got an inside function of 1 minus x squared and an outside function of sine. So differentiating the inside function first, it's always inside then outside. So it's minus 2x multiplied by sine differentiated, which is cos of the inside function, 1 minus x squared. And there we are, that's the answer to this question. Next one we've got the product rule. We've got sine 3x multiplying by e to the 7x. So it's sine 3x is one function, another function is e to the 7x. So let's get started on differentiating this. So we differentiate the f function first, sine 3x. That will differentiate to 3 cos 3x. And hopefully you've got familiar with, if there's a scale factor on the inside, when you differentiate, the scale factor gets moved to the front and kept inside the function as well. So that's that part differentiated. We've done that part now. So multiply it by the e to the 7x function. And we've differentiated one of them, kept the other one the same. Now we'll do it the other way around. Sine 3x is the same, and e to the 7x differentiates to 7e to the 7x. So tidying this up, we could also factorize out e to the 7x. It's going to be 3 cos 3x plus 7 sine 3x. And there we are, that's the answer to this question. Okay, this question is e to the x plus sine x all to the power of 7. Well, this is another chain rule. The inside function here is this part here, e to the x plus sine x, and the outside function is the power of 7. So let's just write that down. the inside function is e to the x plus sine x, and the outside function is the power of 7. So that's x to the power of 7. So let's start differentiating. dy by dx equals the inside function differentiated first, that's e to the x plus cos x, and then multiply that by the derivative of the f function. Well, using first year differentiation, this is 7x to the 6, but it's not going to be 7x to the 6, it's going to be 7 times the inside function g, e to the x plus sine x, all to the power of 6. Okay, so this x here gets replaced with the g function. And that's the final answer. You could probably tidy it up by putting the 7 at the front, but not much is going to happen apart from that. You can't mix together the insides of one and the other because one of them has a power of 6 on it and the other one doesn't. Even if they both did, you couldn't mix them up. Right, so there we are. That's the answer to this question. Next one, we have ln of sine 4x. So this is an inside function, outside function question. The inside function here is sine 4x. The outside function is ln. So let's get started on differentiating this. The inside function is sine 4x, so that will differentiate to 4 cos 4x. And then the differential of the outside function is 1 over x, but it's not 1 over x, it's 1 over the inside function sine 4x. So putting this together, we get 4 cot 4x, because cos over sine is cot. Next one, we clearly have two functions one over another. It's a fraction, so we really have to use the quotient rule here. It's really important you label the top one f and the bottom one g. So let's get started on differentiating this. You get the differentiation rule in the formula booklet, so you don't need to remember it, but it's really long and complicated, so it's good to have some practice. First of all, we need to differentiate the f function, which is minus sine x, times the g function, e to the 7x. Take away the f function, which is cos, multiplied by the derivative of the g function, that would be 7e to the 7x. All over the g function squared, that's e to the 7x, all being squared. So in this case we could cancel out an e to the 7x on top and bottom. Well, we'll just cancel out one of them. So it's going to be minus sine x minus cos x times 7, so I'll put the 7 at the front of that, all over e to the 7x. And there we are, that's the answer to this question. Okay, so next one we have ln x to the 4. Remember, with these we can use cheeky little laws of logs to help us with this question. We can rewrite this. If it's a power inside the bracket, it's a scale factor outside the bracket. So now it's just 4 multiplied by ln x. So the answer to the derivative is going to be 4 times by the derivative of ln x, which is 1 over x. And 4 times 1 over x is 4 over x. So that's the answer to this question. Next one, we can do something very similar here, splitting it up using the laws of logs. If we take 5x cubed, then well, let's split up the 5 and the x cubed first. That would be ln 5 plus ln x cubed. But remember, if it's a power inside the bracket, it's a scale factor outside the bracket. Okay, now let's differentiate. Ln 5. What is ln 5? Well, ln 5 is actually a numerical value. You can think of this as just the number 7. How would you differentiate the number 7? It differentiates to 0. So the same will happen with ln 5. It just disappears because it's just a numerical value. It has nothing to do with x. The next one is going to be 3 over x because ln differentiates to 1 over x. Times that by 3 and you get 3 over x. So that's the answer. Next one, so try and spot this one on your own. It's the inside function of x cubed plus 2 and the outside function of the square root. So these are pretty difficult to spot, but it's the inside of the square root that's the inside function, and it's the actual square root symbol that's the outside function. Let's get started on differentiating this. It's going to be the inside function differentiated, that's 3x squared, multiplied by the outside function differentiated. Remember, this is effectively x to the half, so it's going to differentiate to a half x to the minus half, but it's not x that's going to be there, it's going to be x cubed plus 2. So it's going to be multiplied by a half bracket x cubed plus 2 to the power of minus a half. So it's going to be 3x squared over 2x cubed plus 2 square rooted. Okay, so there we are, that's the answer to this question. Moving on to the next one, this one here again is using the laws of logs. So it's ln bracket 7x, and this is all to the power of a half because that's the square root of 7x. So we can bring powers out, so this is going to be now a half ln 7x. The next thing we'll do is we'll split up the 7 and the x, so this will become a half ln 7 plus a half ln x. Now let's differentiate. So half ln 7, that's just a numerical value. It has nothing to do with x in it, so that just disappears when we differentiate. A half ln x, that's going to turn into 1 over 2x when differentiated, because it's going to be a half times 1 over x, so it's 1 over 2x. Next one, it's clearly the quotient rule again, because we have a top function and a bottom function on the bottom of a fraction. So let's get started differentiating. What's really important with these is that you set the top function equal to f and the bottom function equal to g. So let's get started. We have the derivative of the f function, that's 5x to the 4, times by the g function, sine 2x. Take away, because that's the sign in the middle, f of x times by the derivative of g of x. So that's going to be 2 cos 2x. All over the bottom function squared, sine squared 2x. Let's just tidy this up. It's going to be 5x 4 sine 2x minus 2x to the 5 cos 2x all over sine squared 2x. And there we are, that's the answer. Moving on to the next one. This one's pretty difficult to spot. Y equals sine to the power of 5x. Well, in this case, actually what's happening is it looks like this. Sine function is the inside function, and it's the power of 5 that's the outside function. So in this case, it's g of x equals sine x, and f of x, the outside function, is x to the power of 5, or the power of 5 function. So let's get started on the differentiation. Differentiate the inside function first, that's cos x. Differentiate the outside function second, that's going to turn into 5x to the 4, but it's not x, it's the inside function that it's going to be of. So it's going to be 5 sine x to the power of 4. So this is going to turn into 5 cos x sine to the power of 4x. So there we are. Moving on to the next one, cos squared. You could do this in two different ways. You can think of it as cos times cos, product rule it, or we can do the rule that we used before, cos to the power of 2. So this is again going to be the quotient rule. So not the quotient rule, the chain rule. It's going to be looking like this, cos of x squared, like that. So the inside function is cos x, the outside function is x squared. So let's differentiate this. Differentiate the inside first, that turns into minus sine. and then differentiate the outside function x squared, that's going to become 2x, or 2 cos. So this is going to simplify to minus 2 sine x cos x. You probably recognise this using the double angle formula of minus sine 2x. So there we are, that's the answer to this question. Moving on to the next one, we have y equals the square root of sine x. So in this case, again, it's the chain rule. The inside function is sine x, the outside function is square root. So let's start differentiating. Differentiate the inside function first. Sine differentiates to cos. And the square root of x, well, if it's x to the power of a half, this will turn into a half x to the minus half. So it's going to become multiplied by a half times the inside function. It's not going to be x, it's going to be the inside function sine to the power of minus a half. So the answer simplified is going to be cos over 2 root sine x. And there we are, that's the answer to this question. Next one, cos of 1 over x. Well, this clearly is another chain rule. The inside function here is 1 over x, the outside function is cos x. So let's just write this down because there's a little shortcut to this. If it's 1 over x, you can think of this as x to the minus 1. So when you differentiate it, it's going to become minus 1, the power moves to the front, and then take away 1 from the power, x to the minus 2. Or in other words, minus x to the minus 2. So let's get started on the differentiation. Differentiate the inside first, well that's what we've just been working on. The inside function differentiates to minus x to the minus 2. Multiply that by the differential of the outside function cos, well that would be minus sine of 1 over x. So double negative will make it positive, and to simplify this, it's going to be sine of 1 over x over x squared, because this is x to the minus 2. This triple tiered fraction is not really a triple tiered fraction because it's inside a sine function on the top, so this is absolutely fine as an answer. Moving on to the next one. Sine of 1 over x squared. Well, very similar to the last one. The inside function in this case is going to be x to the minus 2. So let's differentiate that. It's going to become minus 2 x to the minus 3. So let's get started on differentiating this. It's going to be using the chain rule again. So we're differentiating the inside function first, as always. Minus 2x to the minus 3. Multiply that by the differential of the outside function, cos of the inside function, 1 over x squared. So to simplify this as a final answer, it's going to be minus 2 cos 1 over x squared over x cubed. Okay. Moving on to the next one. Moving on to the next one, 1 over ln. So in this case here we're going to use the quotient rule. The top function is, well, that's just 1, that's f, and the bottom function is g. 1 and g. So let's get started using this quotient rule. Differentiate the top function first. So 1 differentiates to 0. Multiply that by, well, it doesn't really matter when I'm multiplying it by, it's 0, so it doesn't really matter. Take away the f function 1 multiplied by the derivative of the g function, that would be 1 over x, over the g function squared, that's going to be ln of x squared. So let's simplify this to minus 1 over x over ln x all squared. And this will simplify to 1 over x ln of x squared. Just like that. Just to highlight something, there is a difference between ln x squared and ln of x all being squared. These two things are not the same, so don't accidentally get those confused. Next one is 1 over x squared. So again, we've got a fraction, and here we need to differentiate using the quotient rule. So let's get started. dy by dx equals, remember the top function is f, the bottom function is g. So the top differentiated first, that's 0, so it doesn't really matter what comes next, minus the f function 1 multiplied by the derivative of the g function 2x over the g function squared, that's 1 plus x squared all squared. So the answer simplified here is minus 2x over 1 plus x squared all squared. Okay. Moving on to the next one. Right then, moving on to the next one, we have y equals tan here. Now we're going to differentiate tan using the quotient rule. And you're probably thinking, well, how do you differentiate tan using the quotient rule? It's not a fraction. But what we're going to do is we're going to consider y as sine over cos. So we're going to consider tan by its identity of sine over cos, and then we'll set the top function to f, the bottom function to g, and then differentiate using the quotient rule. So let's get started. First of all, we need to differentiate the f function, that's sine, so that becomes cos. Multiply that by the g function, which is cos again. Then take away the f function, that's sine. Multiply by the differential of the g function, that's the bottom one, cos, that differentiates to minus sine. So it's going to be minus sine here all over cos squared. Let's just have a look at tidying up the top now. The top will tidy up to cos squared. And then there's a double negative on the right hand side. Minus times a minus is a plus. That would be plus sine squared over cos squared. And we all know that cos squared plus sine squared is 1. So it's 1 over cos squared x. So we know that this differentiates to sec squared. So there we are, that's the answer to this question. So what you can now use is the derivative of tan is equal to sec squared. Moving on to the next one, sec x here. And again, we're going to be using the quotient rule to differentiate this. We're going to be considering the fraction 1 over cos x and differentiating that. So we know the top is f, the bottom is g, and now we'll use the quotient rule. So dy by dx is equal to the derivative of the top, that's 0. So it doesn't really matter what g is, it's times in by 0. So take away the f function 1 times by the derivative of the g function, that would be minus sine. And that's all going to be over the bottom squared, that's cos squared. Let's simplify this a little bit. Minus times a minus is a positive, so it would be sine x over cos squared. So this is the answer to the derivative, but we'll just split it up a little bit more. We'll split it up into 1 over cos times sine over cos. So therefore the answer to this derivative is sec x tan x. Okay, so there we are, that's the answer to this question. Moving on to the next one, you can probably guess what the next one's going to be, cos x. Let's get started on cos x. Once again, we're differentiating using the quotient rule. We have here y equals 1 over sine x. So once again, the top function is f, the bottom function is g, and let's get started using the quotient rule. So the derivative of the f function first, 1 differentiates to 0. It doesn't really matter what g therefore is, so we'll just carry on. Minus the f function, that's 1, times by the derivative of the g function, that'll make it plus cos. And then over g squared, so that's going to make it over sine squared x. So that's going to be minus cos x over sine squared, tidying it up a little bit. And then in a very similar way to the previous derivative, we're going to split it up and make it cos over sine times 1 over sine. So in this case here, the answer is going to be minus cosec x cot x. And there we are, that's the answer to this derivative. Next one, Cot X. So once again, we're going to be using the quotient rule, so we're going to set this to be cos over sine. And the top function will be f, and the bottom function will be g. So let's get started using the quotient rule. The derivative of the f function first, that would be minus sine, times by the g function, sine. Take away the f function, which is cos, times by the derivative of the g function, that would be cos again. All over g squared, so that's going to be sine squared. Let's simplify this. It's going to be minus sine squared x minus cos squared x. You can kind of see what might need to happen on the top. Unfortunately, we've got negatives in there, so what we'll do is we'll factorise out the negative to the front of the fraction, and it will then be sine squared plus cos squared over sine squared. Then this will equal minus 1 over sine squared, which is therefore minus cos x squared. So there we are, that's the answer to this derivative. Right, so now that we've gone through these four, we've gone through, let me show you, we've gone through tan x, the derivative is sec squared, the derivative of sec is sec tan, the derivative of cosec is minus cosec cot, and the derivative of cot is minus cosec squared. You get these four in the formula booklet. So for y, the y function, when it's tan, sec, cosec and cot, these are your derivatives, and if it's inside the context of a question such as this one here, you can just use the fact that tan differentiates to sec squared straight away, rather than having to go through the whole process of quotient rule each time. So we're now working on this question here, y equals tan 5x plus 9, and we're going to be using the chain rule here. The inside function is 5x plus 9, and the outside function is tan. So let's get started on using the chain rule here. So it's dy by dx. Differentiate the inside first. 5x plus 9 differentiates to 5. Then it's going to be multiplied by the derivative of the outside function, tan. Tan differentiates to sec squared, but it's sec squared of the inside function, 5x plus 9. And there we are, that's the answer to this question then. So you can use these four derivatives in the context of another question. If it asks you to prove that the tan derivative is sec squared, then you obviously got to go through that whole process we've just been through. But if it's just differentiate this, you can recall this fact from the formula booklet. Let's move on to the next one. Sec 4x e to the 9x. Well, this here is going to be the product rule. We have two functions that are being multiplied together. We have sec 4x and e to the 9x, but inside there is a 4 and a 9 inside both of our two functions. So remember, when we differentiate these 4 and this 9 will kind of pop to the front as a scale factor and will also stay inside the brackets. So let's get started on this derivative. So first of all, we differentiate the f function first. Sec differentiates to sec tan, but because there's a 4 inside, the 4 is going to pop out to the front as well as staying inside the bracket. So it would be 4 sec 4x tan 4x, so the 4x appears in both of these positions, sec and tan, when it's differentiated. So the 4 gets differentiated out to the front, but also into both positions next to the 4x, next to the x in sec, and next to the x in tan. Let's carry on with this derivative. Multiplied by g of x, that's e to the 9x. And then this is going to be plus the original f function, sec 4x. And then it's going to be the derivative of the g function, that will make it 9 e to the 9x. And that's the answer to this question then. So it was helpful seeing how we differentiate sec 4x. The 4 pops out to the front, but also is involved in both of the angles in sec and tan. Let's move on to the next one. This one here, we clearly have a fraction, don't we? So it's quotient rule. We have the top f of x, that's cosec 5x, and on the top it's ln 2x. That would be our g function. So let's get started on the derivative of this using the quotient rule. First of all, we need to differentiate the f function. That's the top one, so that's going to be minus cosec cot, but there's a 5 inside there, so that 5 will also pop out to the front, and it will stay inside both of the brackets of our derivative. Cosec 5x and cot 5x. Then that's going to be multiplied by the g function, that's ln 2x. And then we're going to take away the f function, that will be cosec 5x, multiplied by the derivative of the ln 2x. Now remember, ln 2x is dealt with like this. We split it up into ln 2 add ln x. Ln 2 is just a number, so we can kind of cancel that out to be when it's differentiated. And then ln x differentiates to 1 over x, so the answer here is 1 over x. This is all going to be over g squared, that would be ln 2x all squared. And there we are. We could probably simplify this if we were looking to, but I'm just going to leave the final answer like this. This is the answer to the derivative of this function here. Moving on to the next one, cot 5x squared. Well, this here is going to be a case of the chain rule. We have one function 5x squared inside another function cot. So let's get started on differentiating this. Differentiate the inside function first. 5x squared differentiates to 10x. And then cot differentiates to minus cosec squared. So this is going to be times minus cosec squared. And then it's of the inside function 5x squared. So the answer to this question is minus 10x cosec squared 5x squared. So the derivative of the inside function popped out to the front, and then we differentiated cot to minus cosec squared, and that's our final answer. Moving on to the next one. Ln sec, well here again we have the chain rule, we have one function inside the other function. So it's going to be sec as our inside function and ln as our outside function. So let's get started on this derivative. The inside function sec differentiates to sec tan. And then the outside function next, the ln function, well, ln of x differentiates to 1 over x, but it's not going to be 1 over x, it's going to be 1 over sec in this case. 1 over sec. And we can see here that the sec and the sec will cancel out on top and bottom, so we're left just with tan. Okay. Moving on to the next one. Ln 6x cosec 9x. Well, this here is a case of the product rule. We've got two functions that are being multiplied together. Ln 6x and cosec 9x. Let's just remind ourselves what happens with ln 6x. We break it up into ln 6 and ln x. When we differentiate, ln 6 is just a number, so that will disappear, and ln x turns into 1 over x. So let's now get started on this full derivative. The first thing we need to do is we need to differentiate the first function. We've just done that down there. That's 1 over x. Multiply it by the g function. That would be cosec 9x. Then it's going to be add the original f function, ln 6x, multiplied by the derivative of the g function, cosec 9x. So remember, that 9 is going to pop out to the front, so it's going to be times minus 9, minus because there's a minus for the cosec derivative, minus 9 cosec 9x cot 9x. Okay, and there we are, that's the answer to this question. Moving on to the next one, we have cot square root x. So in this case here, it's the chain rule. We have an inside function of square root x, and we have an outside function of cot. So let's get started on using the chain rule here. Inside function first, the derivative of x of square root x. Remember, square root x is the same as x to the half, so we differentiate it using the rule of bring the power down to the front and reduce the power by 1. So that's going to be a half x to the minus half. We might sort that out in a bit. And then that outside function, cot differentiates to minus cos x squared of the inside function root x. Let's just finish this final answer off. It's going to be minus 1 over 2 root x times by cos x squared root x. And there we are, that's the answer to this question. Next one, square root of cot x, so it's the other way around this time. So the inside function this time is going to be cot, and the outside function is going to be the square root. So let's get started using the chain rule. Differentiating the inside function first, cot differentiates to minus cos x squared. And this is going to be multiplied by the derivative of the square root function. The square root function is kind of like x to the half. So differentiating x to the half, you differentiate by bringing the power down to the front and reducing the power by 1. So in this case it's going to be a half, but it's not going to be x to the power of minus half, it's going to be the inside function to the power of minus a half, which makes it cot x to the power of minus a half. Let's simplify this where we can. It's going to be minus cos x squared x over 2 lots of the square root of cot x. And there we are, that's the answer to this question. Right then, moving on to the next one, we have another case of the chain rule here. We have the sec function inside the e function. So that's going to be the inside function of sec, outside function of e. So let's get started on this using the chain rule derivative. So the inside function sec first, that differentiates to sec x tan x. Then it's going to be multiplied by the derivative of the e function. The e function differentiates to itself, so it's going to be e sec x. And there we are, that's the answer to this question. Moving on to the next one, square root of cos x. So here again we have the chain rule. The inside function is cos x, the outside function is square root. So let's get started on the chain rule. Inside function first, cos x differentiates to minus cos x cot. And then the outside function second, square root. Well, the square root is like x to the half, which differentiates to bring the power to the front, reduce the power by 1. So this is going to be equal to 1/2 brackets, but it's not half x, it's half of the inside function cos x to the power of minus a half. So I think we could do probably some simplifying here. It's going to be cos x cot x over 2 root cos x. But we could probably simplify some of these cos x on top and bottom. This will end up with minus 1/2 root cos x cot x. And there we are, that's the answer to this question. Let's move on to the next one. So ln tan. So this is another case of the chain rule. We've got the inside function of tan, the outside function of ln. So let's get started using the chain rule. The derivative of the inside function first is sec squared. And then this is going to be multiplied by the derivative of ln. Remember, ln of x differentiates to 1 over x, but it's not going to be 1 over x, it's going to be 1 over the inside function, so it's going to be 1 over tan. Let's see if we can simplify this a little bit. It's going to be 1 over cos squared. This is cot, so it would be cos over sine So cancel out a cos from top and bottom, and you end up with 1 over cos x sine x. And there we are, that's the answer to this question. Moving on to the next one, cos x squared. So the inside function here is going to be cos x, and the outside function is going to be the power of 2. So let's get started on the derivative here. The inside function cos x differentiates, well, yeah, I'll show you how we think of it. We think of it as cos x all squared. So hopefully that makes it a little bit more clear that that's the inside function and the outside function is the power of 2. So the inside function first, that is minus cos x cot x multiplied by, now how does x squared differentiate? Well, it differentiates just to 2x, so in this case it's going to be 2, but it's not x, it's the inside function cos x. Simplifying this back together, it's going to be minus 2 cos x squared x cot x. Okay, so there we are. Moving on to the next one, cot squared 2x. Well, in this case here, this is a little bit more tricky. It's going to be cot 2x that's inside the bracket. That's the inside function, and then square is going to be the outside function. So the derivative in this case, derivative of cot 2x is going to be minus the 2. Remember, if the 2's inside the bracket, that pops out as a scale factor as well by the chain rule. Minus 2 cos x squared 2x multiplied by, now we need to differentiate the x squared function. The x squared function differentiates to 2x, but it's not going to be x squared, it was cot 2x squared, so it's going to be 2 cot 2x. 2 lots of the inside function. And we'll simplify this together, minus 4 cos x squared 2x cot 2x. And there we are, that's the answer. Moving on to the next one. Sec of 1 over x. So in this case here we have the inside function of 1 over x, the outside function of cos. So remember 1 over x, that's the same as x to the power of minus 1. So the way we differentiate that is we bring the power to the front and reduce the power by 1. So it's minus x to the minus 2. Let's get started on the full differentiation of it. First we do the inside function, that's what we've just done down here, minus x to the power of minus 2. And then the outside function, sec, is sec tan, so it's going to be sec 1 over x, tan 1 over x. And that's the final answer to this question. Moving on to the next one, ln cosec. Well, in this case here we clearly have a chain rule again, inside function of cosec, outside function of ln. So in this case, let's start using the chain rule. Cosec differentiates to minus cosec cot. And then the outside function, ln, well, ln of x differentiates to 1 over x. But it's not going to be 1 over x, it's going to be 1 over the inside function. So it's going to be 1 over cosec. Cancel out top and bottom, and we're left with minus cot. So there we are, that's the answer to this question. Moving on to the next one. In this case here we have a fraction, so it's clearly e to the 7x over sec x. This is going to be using the quotient rule. What you could do, we won't do it in this video, but what you could do is remind yourself that sec is 1 over cos, and turn this into e to the 7x cos x, and differentiate it using the product rule. That'd probably be a better way of doing it. I'm going to carry on doing it by the quotient rule, but you could do it by the product rule as well, just by doing a little bit of rearranging. So let's start differentiating this function as it was previously. Derivative of the f function, remember f is on the top, g is on the bottom. So the derivative of the f function is 7e to the 7x multiplied by the g function, that's sec x. Subtract the f function, e to the 7x, multiplied by the derivative of the g function, Sec differentiates to sec tan. And this is all going to be over sec squared. Whoops, sec squared. We could probably cancel out sec from top and bottom. And we could probably factorise out the e to the 7x at the front, e to the 7x bracket, 7 minus tan x over sec x. And there we are, that's the answer to this question. Moving on to the next one, 1 over the square root of square root of 1 minus x squared. Well, this is nothing to do with sec, tan, cosec or cot, but this is how you would differentiate it. We're going to rewrite the y function as 1 minus x squared to the power of minus a half. So the inside function here is the bit inside the bracket. The outside function is the power of minus a half. So let's get started on the derivative. The inside function differentiated is minus 2x. And then let's think about the outside function, x to the power of minus a half. Bring the power to the front, reduce the power by 1. So it'll now be minus 3 over 2. So it's going to be times, but it's not x, it's the inside function. So it's going to be 1 minus x squared. Whoops, we've got to times by a half, didn't we? Minus a half, and then it'd be minus 3 over 2. Simplifying this, it's just going to be minus x over 1 minus x squared to the power of minus 3 over 2. And there we are, that's the answer to this question. Moving on to the next one. Ln cot x, well this is another chain rule one. Inside function of cot, outside function of ln. So in this case, let's start differentiating. Cot differentiates to minus cos x squared. And ln, remember the ln function, ln x, differentiates to 1 over x. But it's not going to be 1 over x, it's going to be 1 over the inside function. So that would be times by 1 over cot x. So in this case here, the final answer being cos x squared x over cot x. Could probably simplify here. Let's make it 1 over sine squared. 1 over cot is tan, so this is going to be sine over cos. Simplify a sine from top and bottom, and you end up with minus 1 over sine x cos x. And there we are, that's the answer to this question. Okay, next question, so we're on y equals sec 1 over square root of x. This is going to be chain rule again. Inside function of 1 over the square root of x, outside function of sec. So, what do we do with this 1 over x square rooted? We can treat this as x to the power of minus a half. Minus because there's a fraction, half because it's a square root symbol. And what happens when we square root and when we differentiate this? It's going to differentiate to minus half x to the minus 3 over 2. So that's what we're going to use instead of 1 over the square root of x. So let's get started on the full differentiation now. Differentiating the inside function first. Well, that's what we were doing down here. So it's minus a half x to the minus 3 over 2. Then differentiate the outside function sec. Sec differentiates to sec tan. Remember the 1 over the square root of x will be inside both of the sec function and the tan function. So there we are, that's the answer to this question. Let's move on to the next one. 5 to the power of x. Okay, so let me show you how you differentiate this one. I'll show you the proof for it, and then I'll show you what the trick is in the next question. So what we do here is we start with y equals 5 to the power of x. And first of all, we take lns of both sides. So ln of y and ln of 5x, 5 to the power of x. So we've just done the operation of lnning both sides of this equation, basically. What we can do now on the right hand side is turn this into x ln 5. And on the left hand side it will stay as ln y. Let's now e both sides, so e to the power of the left and e to the power of the right. So e to the ln, well that's just reverse operations, that's just back to y. But on the right hand side it's something slightly different, it's x ln 5. Now remember that ln 5 is just a number, so it's effectively just e to the some number x. And let's think about differentiating this now. It's a is kind of like a scale factor, that goes to the front and remains at the top of the power with the e. Which is what's going to happen here. It's going to be dy by dx equals ln 5 e to the x ln 5. So the ln 5 here is kind of like the scale factor multiplier on the x here. Differentiate the inside function first, that would be ln 5, and then outside function second e, that stays as it was before. But let's now write it as a final answer, so it's going to be ln 5. We know that this part here is the same as y, because it says so here, it's equal to it. But we also know that y is equal to this thing up here. So it's ln 5, 5 to the power of x. And that's your answer to the derivative. It's ln 5, 5 to the power of x. So you can kind of spot the pattern here. If it's any number to the power of x, then it differentiates to ln of that number, a to the power of x. And so if we go to the next one, 7 to the power of x, so we should just now know the rule. It's going to go to ln 7 times 7 to the power of x. It might be a show that question. If it's worth 1 mark, then just write the answer. If it's worth 3 or more marks, then write a proof for it, just like we did here. Okay, moving on to the next one now. So combining what we've done before, so we're going to remember how to differentiate 3 to the x. We've also got sec involved as well. This question here is a product rule differentiation. We've got two functions that are being multiplied together, so let's start differentiating them. Sec x is the first one to be differentiated. That will go to sec x tan x, multiplied by the original g function, that's 3 to the power of x, and then plus the original f function, that was sec x, times the derivative of the g function, that is ln 3, 3 to the power of x. And that's your final answer. Moving on to the next one, sine 3 to the power of x. So this is going to be a chain rule differentiation, inside function being 3 to the power of x, outside function being sine. So let's get started on this differentiation. Inside function first, derivative of 3 to the power of x is ln 3, 3 to the power of x. And then the outside function second, sine differentiates to cos of the inside function. And there we are, that's the answer to this question. Moving on to the next one, 4 to the power of minus x. Well, here we have a chain rule again, inside function being the minus x operation, and then 4 to the power of x is the outside function. So in this case here, dy by dx is equal to minus x differentiated is just minus 1, and then it's 4 to the power of x, that's the next function, so it's going to be ln 4, 4 to the power of minus x. And there we are, that's the answer to this question. You could also have thought of this question as, okay, so 4 to the power of minus x, that's the same as 4 to the minus 1 to the power of x. 4 to the power of minus 1, that's a quarter to the power of x, and now we can just differentiate this. That's going to be ln quarter times a quarter to the power of x, which is exactly the same actually as what you get here. So both derivatives are exactly equal, just done in a different way. Next one, 1 over the square root of sine x. Well, this one's a little bit strange. What we do with this is we deal with this as sine x inside the function to the power of minus a half outside the function. That is how we turn the 1 over the square root of x into an indice. It's minus to the power of half. So let's start differentiating. We have the inside function first, sine differentiates to cos. And then the outside function is x to the minus half, which differentiates to minus half x to the minus 3 over 2. And that's what it's going to be. It's going to be minus half. It's not going to be x, it's going to be sine though, so it's going to be sine x to the power of minus 3 over 2. We could probably simplify this answer, minus cos x over 2 bracket sine x to the power 3 over 2. And there we are, that's the answer to this question. Moving on to the next one. We have 7 over 3x plus 5 all to the power of 7. So again, chain rule, the inside function is going to be 3x plus 5, and the outside function is going to be this 7x to this minus 7. So let's rewrite it as we wish to differentiate it. Y is going to equal 7 bracket 3x plus 5 to the power of minus 7. We could have done this by the quotient rule, but I'm going to do it by the chain rule instead, treating the 7 as a power of minus 7 if it's on the bottom of a fraction. So basically we can just leave this 7 at the front alone. The answer to our derivative is just going to then be multiplied by 7. So let's differentiate the inside function. We'll put the 7 at the start just to get the ball rolling. Differentiate the inside function first, that's going to be 3. Then differentiate the outside function. The outside function is effectively minus x to the minus 7. So bring the power to the front, reduce the power by 1, minus 8 now. So that would be times minus 7. But it's not x, I'm not going to use x, we use the inside function, 3x plus 5 to the power of minus 8. So in this case it's going to be, well, 49 times 3 minus 147 over 3x plus 5 to the power of 8. And that's the answer to the derivative. Moving on to the next one, cot 3x squared. Well, in this case here we have an inside function and an outside function. So let's get started on this differentiation. The inside function is 6x differentiated. The outside function cot differentiates to minus cos x squared 3x squared. And that's the final answer to this question. Moving on to the next one. Now the next one's a little bit of a cheeky one here. We could think of this as 1 over cos times, so divided by 1 over sine. And actually this is equivalent to sine over cos, which is equivalent to tan. So effectively what we're doing here is we're just now differentiating tan. So you can always just manipulate your trig functions to help you with your differentiation if you need to, just like I am here, to make the life easier for yourself. Differential of tan is sec squared, and that's our answer. Moving on to the next one, y equals the square root of tan 7x plus 3. So this is going to be the chain rule. The inside function being tan 7x plus 3, the outside being the square root. So let's get started differentiating. The inside function is tan 7x plus 3, but inside that we also have another inside function, so you can think of this as a 3-layered chain rule if you want to. Or you can just remember that the 7 will multiply to the front as a scale factor, but the 3 just doesn't do anything really, it will just stay inside the bracket. So tan differentiates to sec squared, so it's sec squared 7x plus 3, but whoops, I forgot to put the 7 to the front because that needs to be multiplied as a scale factor at the front. The 3, if you think of it, it's going to be 7x plus 3 differentiated, moved to the front, that's why the 3 disappears. Then it's going to be x to the half as our outside function, differentiating this is a half x to the minus half. So this is going to be multiplied by a half, but not x, it's the inside function, tan 7x plus 3, all to the power of minus a half. So this answer is going to be 7 sec squared 7x plus 3, all over 2 square root tan 7x plus 3. And there we are, that's the answer to this question. Next one, 1 over the square root of ln x. So in this case here, again, it's the chain rule. Inside function being ln, outside function being a power of minus half. So let's get started on this differentiation. Inside function first, ln differentiates to 1 over x. Outside function, now the outside function is actually x to the minus half. So this will differentiate to minus a half, x to the minus 3 over 2. So that's what it's going to be. It's going to be minus a half, but it's not x, it's the inside function, so it's going to be ln of x to the minus 3 over 2. So simplifying this answer, it's going to be 1 over, well, minus 2x bracket ln x to the 3 over 2. And that's the answer to this question. Moving on to the next one. The inside function here is quite a big one. It's all of that thing there, sine x plus cos 2x. And then the outside function is the power of 3 over 2. So let's get started on this differentiation. The inside function first, sine differentiates to cos. And cos 2x differentiates to minus 2 sine 2x. Now the outside function, the power of 3 over 2 will differentiate to 3 over 2 x to the half. So this is then going to be equal to 3 over 2. So this is going to differentiate to 3 over 2, but it's not x that's going to be there, it's going to be this inside function cos x. Sorry, no, the inside function was originally this one, sine x plus cos 2x. And then this will all be to the power of a half. Let's write this out simplified. It's going to be 3 over 2 bracket cos x minus 2 sine 2x multiplied by the square root of sine x plus cos 2x. And there we are, that's the answer to this question. Moving on to the next one. Y equals the square root of cosec 5x. Well, in this case, again, it's the chain rule. Inside function being cosec 5x, outside function being the square root. So let's get started on this derivative. Inside function cosec 5x, cosec differentiates to that. The 5 moves to the front as a scale factor, so it's cosec 5x cot 5x. And then we need to differentiate the power of a half. So the power of a half differentiates to a half, x to the minus half. So this is then all going to be multiplied by a half. And then inside the brackets, we're not going to use x, we're going to use the g function, the inside function, cosec 5x, all to the power of minus a half. So what will this simplify to? It will be minus 5 cosec 5x cot 5x over 2 root cosec 5x. And we could probably simplify this to minus 5 over 2 root cosec 5x cot 5x on the outside of that square root. And there we are, that's the answer to this question. And the final question, y equals x to the power of x. Just a warning, you do need to know how to do implicit differentiation for this. It's a couple of sections time from the main section that we've been working on in this video, but you do need to know how to implicitly differentiate. If you've not got there, just leave this one until later on. A couple of weeks' time, you should be fine. Let's get started on this one then. So what we do is we differentiate this using a set of rearrangements first, and then we'll get stuck into differentiating. So what we're going to do first is we're going to take a ln of both sides first. So it's going to be ln of both sides. So ln y equals ln x to the power of x. We're then going to use those laws of logs that can bring the power inside the ln to a scale factor outside the ln. And what we're now going to do is we're now going to differentiate with respect to x on both sides. So on the left hand side it's ln y. So really there's no x on the left hand side, but we do know that y is a function of x, so therefore y can be differentiated with respect to x. The little trick for doing it is differentiating it as normal. Ln y will differentiate to 1 over y normally, but then you multiply by the dy by dx afterwards. Because you're differentiating with respect to the wrong letter, you're differentiating with respect to x, a function of y, so you do need to have this little bit extra on the side. On the right hand side, you're differentiating with respect to the correct letter, so you don't need this extra thing here. On the right hand side, it's the product rule. We've got x multiplied by ln x, so let's use the product rule on it. It's going to be 1 times by ln x, add x times 1 over x. So what does this simplify to? Well, it's going to simplify to 1 over y times dy by dx equals ln x plus 1, because x times 1 over x is just 1. Now we know that y is x to the power of x, so what I'll now do is I'll multiply by x to the power of x onto the right hand side, and this will be my answer. It's x to the power of x bracket ln x plus 1. And that's the final answer to this one. So what you needed at this stage here was some implicit differentiation knowledge. If you've not studied it yet, you will in a couple of weeks' time, no worries. Right then, so thank you very much for watching the full video. Hopefully it's helped you out in your differentiation skills, taking you from beginner level, medium level through to advanced level. This is super advanced level, this differential here. If you do need to come back to the video from time to time just to brush up on your differentiation skills, that's what it's designed for. But thank you very much for watching, and I hope you found it useful.